Welcome back. Last lesson you measured center and spread. Today you learn the shapes data takes. 3 distributions carry almost every probability question on both exams: the normal, the binomial, and the Poisson. The exam rarely asks you to derive them. It asks whether you can pick the right one and read it. That skill is 30 seconds of thought, and it's worth a handful of questions. When we need to compute, I'll use the LeanProjax platform. Let's go. The normal distribution, the bell curve. Continuous measurements, times, weights, diameters, cluster symmetrically around the mean, and 2 numbers describe everything. The mean locates the center, the standard deviation sets the width. Then memorize one rule: 68, 95, 99.7. 1 sigma. Either side of the mean holds 68% of the data. 2 sigma, 95, 3 sigma, 99.7. Both exams test this rule directly, and it's the backbone of control charts in the control phase. The binomial counts successes in a fixed number of trials. 4 conditions: a fixed n, each trial pass or fail, a constant probability p, and independent trials. Inspect 10 units with a 5% defective rate. The chance all 10 pass is 0.95 to the 10th power, about 60%. So even a good line fails an all-or-nothing audit 40% of the time. That's why sampling plans exist. Mean n times p, variance np, times 1 minus p. Keyword on the exam: counting defectives, whole units, good or bad, out of a sample. The Poisson counts events per interval, defects per unit, calls per hour, scratches per panel. 1 parameter, lambda, the average rate, and the property both exams love, the mean and the variance both equal lambda. If a line averages 2 defects per shift, the chance of a defect-free shift is e to the minus 2, about 13.5%. Keyword: counting defects. A single unit can carry 3 of them, or events in time. So which one? Ask what you're counting. Measuring something continuous on a scale. Normal. Counting defective units out of a fixed sample. Binomial. Counting defects or events per interval. Poisson. The defectives versus defects trap decides real exam questions. 10 scratches on 3 panels is Poisson territory. 3 bad panels out of 10 is binomial. Say the sentence, "What am I counting?" before you pick. It's the whole skill. Let's put the normal to work. I'll use the LeanProjax platform. From the toolkit, I open the calculators page, a scratch pad of exam-style calculators, and pick Z to P. Suppose our spec limit sits 1.5 standard deviations above the mean, type 1.5. The calculator reads the standard normal. 93.3% of parts fall below that limit, and the upper tail says 6.7% exceed it. And in reverse, to leave just 1% outside, ask for the 99th percentile. The limit must sit 2.33 sigma out. That's the Z table, without the table. Exam drill. 2 questions. Question 1. You sample 20 invoices and count how many contain at least 1 error. Binomial or Poisson, and why? Pause here if you need a moment. Binomial. You're counting defective invoices out of a fixed sample of 20, each one simply good or bad. Question 2. For a Poisson process averaging 4 defects per hour, what is the variance of defects per hour? Take a few seconds. 4. The Poisson's mean and variance are both lambda. If the exam asks for the standard deviation instead, it's the square root, 2. 3 shapes, 1 question. What am I counting? Add the empirical rule and the Poisson mean equals variance property to your formula sheet. Next lesson, we turn defect counts into the metrics 6 sigma runs on, DPU, DPMO, and sigma level, with worked examples. Subscribe and I'll see you there.